Hello, good morning. We can get started with today's topic. We are going to build a RAG application. Okay. Initially, we are going to build a small LLM application, simple LLM application. Then we are going to build a RAG-based
You
application.
need to put in the hours you're putting in for work is not enough. You need to add in your working hours. You don't have to refer, don't put in the hours. You need to put in good working hours.
Any questions,
Then,
guys?
do you have maths on Saturday? On Friday?
Hello. Okay. So here, guys, we can get started with topic. Okay. Any questions so far, guys? Anyone? Okay. No questions. Okay. So today's session will be very important, guys. Okay. So we are starting building this application. Okay. Let me share my screen. Guys, today we are going to see how do we get started with simple LLM application. Okay. So for that, we are using this. We can use the Google Colab also, but it's recommended to use this VS Code for this purpose. Okay. So how do we download VS Code? We have to go and download this VS Code. Okay. So once we click on in the Google VS Code, we have to type VS Code, and the first link will be there, right? The download VS Code, and according to your system, guys, if you are using the Window, if you are using this Mac, you have to click here. Okay. So it will get downloaded. You can see here it is getting downloaded. Okay. So here guys, if you see here, it getting downloaded, right? The next step is just we have to click here, okay, this version, and just install it. Okay, double click on this, it got install it. Okay, if you click here, it will got the installation. Okay, start for the installation. So already my system it is installed. Okay, so I'm not going to install it again. But here guys, see how do we set up your VS Code? Here are the some steps. Okay, so if you are a VS Code, you want to download the Mac, Linux, or Windows, then install this additional component. These are the not required as of now. We required, but by default, just click on the run. It will got install. Okay. So these are the steps. I will be sharing this link also with you. Okay. You can download and let me open that VS Code. Okay. So here you have to click on VS Code. Okay. New window. Okay, you can see here I have opened this new window for this VS Code. And here guys, we need to create a one folder. Okay, first of all. So let me go back here in the download. What I'll do, I will create a one folder here. Okay. So here the folder is, let's suppose, uh, a RAG project. Okay, this is my folder. I will be utilizing this folder for my project purpose. Okay, so you open folder, download this RAG project. I will be selecting. Okay, you need to click on this. Yes, I trust this. Okay, author. And here guys, see in the VS Code what we are going to do. In the extension we require Python. Okay, Python is required, so you have to download this Python. Okay, so Python is already downloaded. Okay, you have to install this Python. Okay, so only that is the requirement only. then we can get started with the coding. Okay, so here guys, see, this is my folder. In that, here is we can create a file. If you want to create a file, you can click the file.
You're not downloading IntelliSense?
Sorry,
I say you're not downloading IntelliSense?
are you getting some error?
No. I say you're not downloading because you downloaded Python. I say you're not downloading IntelliSense to help with your coding.
Okay, okay. So guys, you can, yeah, we can download it, but as of now, this is the intelligence is not required. Okay, but you can download it as per the your requirement. You can download it. Just you have to download the first of all Python. Okay, and then we can get started, and it will pop up. Okay, whenever you start running the code, it will pop up some of the extension. You can download that extension also. So here, guys, see, let's suppose I'm creating the small simple LLM application. Okay, simple LLM application. Okay, this is my simple LLM application, or we can say .py. Okay, this is my file guys. Okay, if you want to create a folder, you can create folder also. Okay, but as of now we require only file. We are creating the file, and here guys, see what we have to do. Let's suppose we are using the grok. Okay, grok application, and a Gemini also, what all models we are going to use today's lecture. Okay, for that purpose, what we have to do, we have to create a API keys. Okay, so let me create the API key. Grok API key. Okay, so here guys, see what we have to do. Grok API key. So if you click here, it will pop up for the API key. Okay, the Grok API key. We have to install this, and we have to use this. Okay, these are the different models, and let me go API reference API keys. Okay, this one is the API key. So login is required. We have to do the login. Okay, once the post login, it will we are able to create this API key. Okay guys, see here, I'm logged with my Gmail account. Okay, so I have created this API key. Okay, if you want to, you can create on this API key. Okay, you have to give this now name of this API key. My key. Okay, I'm giving this my key as a this one. Okay guys, we have to copy this key. Just copy here, and then open this, and here we have to, how do we store? We have to .env. Okay, this is the environment variable guys. Okay, so here what we have to write? Grok API key equal to this one. Okay, so this how we can store this Grok API key. Okay, clear guys? How we can store this Grok API key in the environment variable? This how we have to store it. Okay, then what is the next step? We have to, let's get started. Okay, for this guys, we require to create one requirement file. Requirements
TXT.
txt. Correct. So here, whatever the requirements required, we will be going to here we will going to install it. Okay, so first install requirement is the Streamlit application. Okay, we are going to Streamlit, use the Streamlit. Then we are using this LangChain. Okay, LangChain Grok. Then we are using this Python.env for this load the environment. Okay, and then we are using this. If required, we are using this YML also, but it's not required as of now. Okay, these are the three things we required. How do we open this terminal to run this code? So here, so if you click on this terminal, guys, okay, this is the terminal on the top side. Okay, click on this new terminal. It will open this new terminal. Okay, you can see here in this terminal, if you some problems we are getting here, you can see the problems. Here it will give the output. Here this is the debug console, and this is the terminal. We are using the mostly this terminal. Okay, and then here guys see we can change the interpreter. Okay, so here we can change this command prompt, PowerShell, Git bash. So here we are using this command prompt. Okay, so any questions? Okay, keys creation of the APIs keys any environment. Let me check. Yes, guys, this is the correct. Okay, this is the correct URL. Okay, you have pasted here. This is the correct URL. So you can use this URL for creation of this Grok API key. Correct.
How could you copy that key, secret key? I'm trying to copy that somehow.
Okay. So here guys see, whenever we create, it will show the pop-up option for the secret key. Okay.
If I miss that to be copied over there.
Okay, then it's again. I think we are not able to do it. We have to copy. Okay, carefully. Otherwise, we have to create a new key. Okay. So let's suppose I have copied and I have pasted and I have done. Okay. So again, it might. Let me try it. Okay, my key submit. Okay, it will not get it. Okay, guys, it will not get it again. You have to create again new key, and while the show just copy it out. Okay, and store it in the place where you can reuse it. Okay, here it will not able to reuse it, recopy it. Okay, got it.
Okay.
Yeah, just create it, recreate it. So here guys see, now what is the next step? So next step is to import this important library. Important libraries. So first library is we have to install, right? We have to install this. Let me here we have to what we have to do. We have to activate this environment. Okay, let me create this. Okay, guys, see now next step is to create a virtual environment. How do we create the virtual environment to install this dependency? Okay, any questions? From example, when I am creating this API key manually using this Elastic Cloud Enterprise, going through Kibana stack management, then go under management, then create API keys. Okay. So guys, okay, this is another method. Okay, so if you want to create, we can also create this way also. That is fine. Okay. So guys, see here. Now, what is the next step? We have to create the virtual environment. Okay. So for this virtual, how we can create the virtual environment? I have created these steps. Okay. So I have written here steps. How do we create this virtual environment? Okay. So here guys see Python yum -m message and then vne virtual environment and then we have to pass this virtual environment name. Okay, so I will be passing this command. I will be copying and just pasting here. Okay, so here guys see it will create the virtual environment. You can see, yes, you want to notice, you notice the new environment have been created. You want to select for your yes, just click on yes. So here guys see this is the virtual environment created. You can see this virtual environment is created here. Then click on this virtual environment script. Okay, it is getting created. Okay guys, it is getting created. Okay, perfect. It is got created. Okay, so what is the next step? So this environment is created. So we have to activate it. Okay, how do we activate it? So we have to write this next step. Okay, virtual environment script activate. Okay, virtual environment script activate. Okay, so this is the one way we can type like this. Okay, so it will activate it. Okay, you can see guys this virtual environment is activated now. Okay, so now what is the next step? Are you following guys? Are you following till now? Or I can
Yeah, we are following.
re.
We are following the installation. We are following.
Okay, okay, great. So what is the next step? We have to create this requirement file, right? Requirements.txt. So we have to install. How do we install? pip install pip install hyphen r.
Yes.
Yeah, requirement.txt. Requirement.txt. Okay, let me copy this. Okay, pip install hyphen r requirement.txt. Okay, guys. So it will collect in these packages. It will install in these packages Streamlit, Langchain Grok, and this python.env. Okay, it is trying to install it. I will be giving these steps here also. So first step is create a requirements.txt file. Okay, and here what we are doing, we have written this requirement.txt, and then we have to, how do we install? Pip install requirement.txt. What are the requirement was there? How many requirement files are there? This many. Okay.
So where you created under the scripts, this one?
Yes, yes, yes. We have to create one file. Okay. So you can see here, guys. See, in this file, I have created this file requirement.txt, and one file is there for this application. Okay, simple LLM application.py.
Okay.
Let me write this as a rename as app.py. Okay, app.py. Okay, so this is my app.py, and this is my what happened requirement.txt. Okay, guys. So I have created these two files requirement.txt. This is the requirement file where I need to install the packages, and this is the app.py is my simple file where I am going to write the code, and this is the environment file. Okay, guys, here environment file I have created this key, and I have stored this key in the inside this environment variable as a grok underscore api underscore key equal to this key I have pasted here. Till now clear, guys?
You have installed under the script same, right? Like pip install something you did it for the.
For this requirement file, right? Pip install hyphen r requirement.txt. Okay, you can see. So what I did here, you can see this is the command, right? Pip install hyphen r requirement.txt.
Install.
You can install one by one package also, but it's recommended to utilize this. Okay, so yeah, pip install hyphen r requirement.txt. Okay, this is the one step. So it is getting installed these packages. Okay, let's wait for these packages. Okay, it is installing. And here, guys, I will be writing. Meantime, I will be started writing the code. Okay, you can see from import Streamlit. Okay, we are using the Streamlit, guys. Streamlit is nothing but the like a Generative application. Okay, we are using the UI Streamlit as AST. Okay, import Streamlit as AST. Then we are using this import OS. Okay, then from langchain dot underscore grok import chart grok. Okay, chart grok. Perfect. So now we have imported. Then from .env, from .env, this is the environment purpose. Okay, guys, .env, we are importing load env. Okay, load env. So we have imported required file. Okay, for .env for this environment variable to load. Okay, for this langchain we are using the chart graph model, and this OS for this system operating system. Okay, guys, and this is the streamlit for this application, web application UI purpose. Okay, guys, see here we have installed these packages. Okay, we have installed these packages. Okay, so now I will write in the script. Okay, observe carefully, guys. Okay, So initialize the model. Okay, you have to initialize this model. How do we initialize this model? So before this initialize the model, we have to load the environment variable. Okay, so load environment variable. Environment variable from .env. Okay, we have stored this right environment variable in the .env file. Okay, then how do we load this? We have to load .env. Okay, this how it will load, and we have to store into some of the variables. Okay, so let me. This is my grok API key. API key equal to os dot get environment. Okay, get env. Then this is my grok API key, right? So what is my grok API? Grok API key. Okay, grok API key. Okay, so here guys see this grok API key is I have stored here. Okay, this is my grok API key. I am loading this dot from this dot e environment. I am loading this key. Okay, this is how I will store it. So you can say we can use this API key from dot env. Okay, dot env file. Okay, environment file we are loading. Then what is the next step? Initialize the model. Initialize the model. Okay, so here LLM we are using. So this is guys free open source. Okay, we can use this chat grok model. Okay, and then we are using the models. Okay, so models you can see if you go to the net. Okay, on this website. So here guys see in the grok cloud they are providing the list of documentation. Okay, you can see in the documentation. Click on the documentation. It is providing these models. Okay, it is providing these models. Okay, so you can see these are the different models they are providing. These are the model ID. Okay, and who is developer of this model is Hugging Face. This Gemma model, who is the developer? This Google. What is the context window length? It has the context window length as 8,000 tokens. This Llama. Okay, this Llama is model also there. Okay, Llama series having three series having different models. Okay, you can see guys, Llama 3.1 70 billion parameter versatile model. It has developed by Meta. What is the context window? 128K. What is max completion token is the 32,000. It is the output guys. Okay, this is the output token. This is the max file maximum size. And more detail you can click here and understand the more details also. And these are the different variants of Llama model. Llama 3.1, 8 billion parameter. This is the instant model. Llama Guard 3.8 billion parameter. Llama 3, 70 billion parameters. We are going to use each and every models. Okay. Then we have this preview models also. Llama 4 is in the preview. Okay. This is going to coming soon. Okay. Llama 4. Llama 4, this Scout model is there. Mauritius model is there. These are the coming soon models. Okay. Mistral, okay, DeepSeek is model also coming. These are the preview models. We can also utilize this model. We are going to see. And how do we can utilize, right? So here guys, API through, we can also utilize this way also through like this, or we can utilize directly through chart grok. Okay, by importing the chart grok using this API. Okay, so here I will utilizing this versatile model. Okay, so this is model I am utilizing. Let's suppose. So here model equal to this versatile model. Okay, and temperature. Okay, here what is the importance of temperature guys? Can anyone tell me why we are using the temperature parameter? Anyone can tell me what is the importance of temperature? Top P, top K. Anyone? So temperature, whenever the temperature is higher, so it will give the creative response. Okay, not a deterministic. And when temperature is the lower means zero, it will give the deterministic answer. Okay, not a creative answer. For this purpose we are randomness, how the randomness required. Based upon this randomness in the response we are using this temperature value. Temperature is minimum means we are getting this very less randomness means very determinist response. Whenever temperature is higher, that is case very random answer, or you can say creative answer. Okay, this is the entry question, guys. Keep in mind. Okay, this is very much important. They will ask top temperature value, what is top P, top K. Okay, so here then we are setting this API key for this model. Okay, this is the model we have set up. Then we have to set up this API key. We have already initialize this API key and we are utilizing here. Okay, perfect. Till now, guys, understood? Any questions? So, guys, now next step is to initialize this Streamlit application. Okay, Streamlit UI. Okay, Streamlit UI. Next step is to initialize this Streamlit UI. Okay. So here, how do I initialize this Streamlit UI? st dot title. Okay, st dot title. In the title, what I'll do? Open source. This is my open source LLM demo. Okay, so this is my open source LLM demo app. Okay, like ChatGPT. Okay, so like ChatGPT, this is my open source LLM app. Okay, demo app. So here, guys, then what we are doing, you are using the form for the input and submit. Okay, so here what we are doing, we are use a form. Form. Why we are using the form for input? Okay, for the user input and submit. Okay, and the submit button. Okay, submit. Okay, so here I see with st dot form. Okay, st dot form. I will use the query form. Okay, this is my query form. I will be using the query form. Okay, you can use the guys. We can see the different variant also. st dot text input also you can use. Okay, here also I can use the st dot text input. Okay, text area or text input also I will be using. Okay, in the next session. But here understand I am using the form. Okay, form. These are the three different way we can use the text input, text area, or we can use this form submit button also, or we can just use the form also. Okay, for the query from the query form. This is my query form underscore. This is my query form. Let me write. You can write it the small or capital, that is not query form. Okay, with the st dot form. Then this will be query. Okay, then I will get the query user query. Okay, so here let's see user query equal to st dot text input text input. Okay, in the text input I'm using this. Okay, I'm using like ask me. So ask me anything. Okay, ask me anything. Okay, so this is how they, and here the submit button, right? So here we what you do, submit it. Okay, we have to use the submit button, right? Yes, submitted. So guys, see, let me run this. Okay, so let me save this and run this. We can check how the progress we have made. Streamlit run app.py. Okay, we have to use this Streamlit run app.py, guys. Okay, this how we can run this application. Okay, so it is getting run. Okay, guys, you can see Streamlit run app.py. It is getting run. Okay, it is getting open also. Okay, you can see it is getting also opening this application web UI. So let me add this step here also. How do we run Streamlit run app.py? Okay, so it is running. Okay, guys, see. So here I have just added this button. Okay, ask me anything. This is the open source. This is the title. Okay, and just added. I have added this here input. Okay, we can pass this input. Right now I have to use this submit button. Okay, So how do I use this? st dot form submit. This will be the I will be using. Okay, st dot submit button. Okay. So ask me anything. After that, we are using this st dot submit button. In the submit button, what we are doing? Just writing the submit. Okay, submit. Okay, submit. And here I will be storing this into the variable into the sum of the submitted. Okay, this is my submitted equal to this is my variable. Okay, I am storing this. Now you can see. Let's save this and you go to UI. Now you can see we have to rerun this. Okay, file changes. Okay, it is rerunning. You can see, guys. I have ready this UI. Okay, so let me ask this question. Hi. Okay, but it will get some error, guys. Okay, it will not show the any response. Okay, you can see, guys. Like how we are using this VS Code because I do at work. So what is your question? Means how we are using the VS Code because I do at work. Yeah, yeah. In the VS Code, we are using this VS Code as a work. Okay, whenever we are working, we are mostly using this VS Code, guys. Okay, and this is the VS Code open source, right? I have just we have to refer this, okay, and download this VS Code. And once the VS Code is downloaded, then we can utilize here. This is the open source, right? We can use in the our own laptop also, own system also. Okay, that is not an issue. So here, guys, see. Yeah, I have typen hi. Okay. So it is not giving any response. Okay, guys, see, it is not giving any response as of now. So here, what we have to do, we have to go ahead and just make the progress. Okay. So here, what I'll do, if submitted, okay, if the submitted, if you click on the submit button, right? Submitted, this submitted, and query. If you ask the query and submit button, okay. At time we require the query, guys. Okay, we require the query and we have to require the submit button. Okay, and here, guys, see. Then we have to try accept. Okay, try in the try button. What we are doing? A response equal to LLM dot invoke. We can use this invoke or run method. Okay, this is the invoke. Okay, this is the invoke, and then what I will doing? I will visit the this is the user. This is the F string, guys. Okay, user, and you can see this is the user query. We are taking this user query to run this LLM application. Okay, and then we are writing the response in the Streamlit UI. Okay, let's suppose we have to write back this response. Okay, in the UI, so st dot write. Then we are using the response. Okay, response dot content. We are getting the content. Okay, response dot content. Will be writing, and then in the exception, what we are doing? Exception. We are handling this, right? Exception, except exception as a E. So here, if error is occurred while this response generating, it will handle this exception. Okay. Then st dot error. We are going to see the what is the error in also in EY. Okay. So n error. Okay. And error occurred. Okay. What is the error occurred? So this is the error occurred as a E. Okay, so here we are writing this exception as a E here, and we are writing this utilizing this error occurred here. Okay, it will show the what is the error occurred. Okay, so here we see now our application is ready. Okay, our application is ready. You can see just we don't have to rerun it. Okay, just we have to save it, and if you want to go here, okay, so here you have to click on this. It will automatically detect. Okay, the file will changes. You have to click on the rerun or always rerun. Okay, both options are there. You can click on the rerun or always run. I will click in here rerun. Okay, so here guys, see, let me submit this button. Okay, it will internally call this. Okay, the LLM, it's nice to meet you. Is there something I can help you with? Okay, So you can see guys, it is getting response. Okay. So let me ask some questions. What is this? Grok. Okay. Okay, see here guys. So Grok Cloud, we ask the question, you get the response like a chat GPT. We are developing the application like a chat GPT. Grok Cloud is a cloud-based platform that provides the access to Grok tensor processing unit and it's the AI-focused hardware. Okay. So Grok is the company specialized in the developing the high performance, low latency computer application, computing solution. And Grok solution platform allows user to deploy and run the AI workloads such as the machine learning models, Grok custom built-in hardware which is designed to accelerate AI computation. Okay, so likewise we saw the Hugging Face, right? It is the likewise open source. Okay, it is also open source. We are using this is the cloud based. Okay, this is also cloud based solution where we can use the different models and they are providing this TensorFlow. Okay, TPU unit for this tensor, which is very fast. Okay, it is this platform is very fast. It will inference time is very fast. Okay, compared to others because they are using this tensor processing unit and it is very fast for the inference. Inference means whenever you submit the query and get the response, it is very fast. Okay, and here we can use this machine learning, LLM, different applications. We can utilize this Grok cloud. Okay, and let's suppose I will ask to what is the Bedrock, AWS Bedrock. Okay, what is this AWS Bedrock service? Okay, so this is my next question. Okay, and it will give in the response. Okay, guys, see here how fast it is getting response. Okay, AWS Bedrock is a fully safe managed service offered by the Amazon Web Services, provide the foundation for the building and running the modern applications. Okay, and simplify the process of building, deploying, and managing the cloud native applications. Okay, so here guys, AWS Bedrock is nothing but they have the services in the provided by the AWS, right? And they are providing this the different APIs. Okay, where we can build the models, deploy the models, manage our service. Okay, and these are the services, pre-configured services. These are the different components. Then AWS Bedrock services include the range of services like AWS Lambda, Amazon Gateway, Amazon DynamoDB S3, AWS IAM role, like this. Okay. So guys, this how we have utilized, right? This how we have utilized this model, right? This ChatGrok model for this inferencing purpose. Let me change the model. Okay. So this is the versatile model. Let me now change the model. Guys, are you following this? This is simple one, right? So firstly I did this model. Okay, now I will be going to change the model to this model. Okay, so let me copy this. Okay, so here what I'm doing, just cut and paste. Okay, you can use any model, guys. Okay, these are the list of models. Okay, you can utilize any of them. Okay, let me write this all this model here so that you can change the models. Okay, so versatile which check this guard model also we can utilize. So here I will be keeping the list of models so that you can later part you can use this. Okay, this model and then this llama 3 billion 70 parameters. Okay, this is also another model. They can you can use this the llama 3 billion 8 billion parameter. Okay, llama 3 8 billion. This is the lightweight. Okay, compared to this 70 billions. Then we can utilize this voice whispers model also. Okay, whispers models also we can use whispers models. Okay, this is the not copy. So they have this different application, guys. Okay, they have this different model for different application. Okay, they are the different models. How do we understand that this model is for the which applications? Okay, so for that purpose, what we have to do? So this is the this model also we can try it out. Okay, guys, this model Metalama Scout. This is the preview model. It is not complete for the production as of now, but this is the preview models. Okay, Llama 4. Then we can use this model also. Then we can utilize Mistral model is also famous model, okay, Mistral. And then we are going to use this DeepSeek model also, okay guys, DeepSeek also we are going to use this. Then we are using this, let's suppose 3.2, okay, that is not required. Okay, this one, 3.21 billion preview, okay, 8 million vision. So this is for the vision purpose, right? Suppose we have this image data script, okay, images there. We can use this image model, okay, for this vision purpose. Okay, this is vision model means for the image data, okay. Whenever we have this deal with the image, I will be showing you some of the example of vision data also. Okay, these are the models we can leverage, okay. And let's suppose I want to know use, okay, so I want to see the details of this model. I will click here, okay, then I can read here, okay. This is the showing in the Hugging Face, guys, okay. This is Meta Llama 3.2 90 billion vision instruct model, okay. I don't have the access for this model, okay, but you can arrange the access by adding this, okay. This is the one form you will get here, and you have to fill your form as a student, okay. You are working as a student and you have to fill this form. They will approve your request. If they are rejected, you have to create new account, okay, for this Hugging Face, and you can again request them for this model, okay. Then you can see this is the Llama model for the images, text, okay. Both we can use the image and text for this purpose. And these are the which language it is supporting, which is English, German, French, Portuguese, Hindi. These are the different eight language supported as of now. And who has developed this model? What is the attention mechanism they have used? Okay, this all this detail you can go ahead and read it. Okay, so this is the multi-model. This is the vision model is multi-model. Okay, this is how we can go ahead and read about these models in details. Okay, now let me change this model. So here guys, initially I have used this model, right? Initially what I did, I have used this model as a Llama 3.370 billion versus right. Now I am using this Llama 3.18 billion instant model, okay? 8 billion instant. And here guys, see, let's suppose I'm making the changes in the temperature, okay? Let me change the temperature as a zero point 0.5, okay? So 0.5 as a temperature value, I'm making the save. Okay, we don't have to rerun it, okay? Let's go here. And just here you can see, it will always detect, okay, source file has changed, we have to rerun it, okay? So it will rerun it, okay? Now same question I will be asking here, okay? You can see. If this model is available, then you can get the response, okay. You can see guys, initially model given the different response, now model is given the some response is the somewhat creative response, okay. Because why it is given the creative response? Because it is the now the temperature value you have changed, okay. Some temperature value we have changed like this, zero point 0.5, let's suppose I will give in the 1, okay, 1.0, okay. This is the temperature value. Now you can see guys, it will change the response, okay. You can see it is the source file is changed. Rerun it, click on this rerun, and then it will same question, let's suppose I'm asking here, okay. Now you can see it is giving somewhat different answer, okay, some creative answer, okay. These are the means it is the somewhat the variation in the response by changing the temperature, okay. Understood guys? This is how we can leverage these different models. For your exercise for you guys is to utilize the different models, okay. These are the different models, okay. You have to utilize, okay. Llama whispers model, Llama 3 whispers model, okay. You can utilize. This is exercise for you, okay. Then what I will go for this Gemini model, okay. So I will, any questions so far, moving ahead. This is a simple model, right guys? This is the very simple models. We are going to utilize rack based model also, but this is the very simple model, okay. Understood? So let me go and create one app, Gemini app. Okay, so this is the app using the Gemini. Okay, Gemini model we are using Gemini.py. Okay, app underscore Gemini.py. Okay, this is my new script. Okay, so here I am using the Gemini model. Okay, guys. So here I need to install this requirement file. In the requirement file, I need to update this. One of the requirement is required. Okay, so guys, this is the requirement for this, only for this. Let me write this code and this, okay, so that you can understand differentiate. Let me copy this code, okay, and where it is, yes. So here, this application, okay. So let me create this. This is the my simple open source app.py using this grok grok API. Okay, grok API. Okay, so this is my script, guys. I will write in this script here, okay, for you. And what is the requirement file? Here I have this requirement file. Okay, this is already requirement file is there for this code. Okay, and then what will I do? So I will be creating now another script. Okay, this is another script for this simple LLM application using the Gemini. Okay, Gemini API. Okay, Gemini API. And here, what is the requirement file is there? Okay, let me write the requirement file here. Requirements dot txt file. Okay, requirement dot txt. Okay, this is the spelling txt. Okay, this is the txt file, and we are going to see how many requirements are required. So there, guys, see in the requirement file, I need to add one more file here. Requirement this Google Generative AI. Okay, because this is the Google Generative AI, because we are using the Gemini model now. Google Generative AI. Okay, this is the requirement file. Okay, so control save. Okay, save, copy. Okay, and here I will be writing this requirement file as this one. Okay, this is my requirement file, and I will be what I'll do, I will be stopping this application. Okay, this one, and I will be now rerunning this. Okay, what is the next step, guys? A requirement, we have to install this requirement file. Pip install -r requirements dot txt. Okay, so we are installing this file. Okay, this requirement updated requirement file. Okay, so it is already installed, right? Python, it is already installed, this Streamlit, LangChain, just it is reinstalling it, this only Google Generative AI. Okay, so you can see it is installing this Google Generative AI. So meantime I will be writing the code. Okay, it is installing same code I am utilizing, guys. Okay, nothing I will be changing here, just I will utilize the same code here. Here, okay, till now I am using the same code. Okay, so here I need to import only another feature also. Google import Google dot generative generative AI as a GenAI. Okay, as a GenAI. So this is how we are utilizing. And here, guys, we have to add the key also, right? We have to add the key. So this is my not a grok API key. Okay, so how I create the key? Let's see, guys. We have to go here, and here we have to create the key. Okay, how do we create the key? Google. Okay, Google Gemini API key. Okay, guys, see here. I have typed this Google Gemini API key, and you have to click on this Google AI Studio. Okay, guys, Google AI Studio API key. Okay. Okay, so here is I have already created this key. Okay, I have already created this key, but let me paste this into the here also. How do we create this key? Okay, here create API key using Google AI Studio. Okay, Google AI Studio. Okay, so this is the link. Okay, this is the AI Studio for this API creation. Okay, so here, guys, what I did, I have actually created. If you create the new key, okay, you have to click. Yes, any questions? Yes, you can ask the questions. Saraswati, you have any questions? Okay.
Yes, Ajit. Hello.
Yes, yes.
Ajit, actually, I'm new to this API concept. How it is calling and what is the purpose? Can you explain?
Okay, okay. So here we are utilizing this model, right? We have to utilize these models, different models. Okay, let's suppose this is the open source model. Okay, they have provided here. Okay, this Grok Cloud has provided this open source model. And how do we utilize these models? We have to utilize this, create the API keys, and from this API keys, we have to store. Let's suppose I have created this API key, and I have to store this API key into the .env. And here guys see, okay, in this I have created this API keys, I have stored and I have loaded this key. Okay, and from this loaded key I will use it directly, I will be using this model. Okay, from this API, just this is the API calls. Why I am doing this API call? Just I want to utilize this model, whatever they have developed these models, I am going to utilize that model. For that purpose I will be utilizing this API.
Model in the sense it's a service.
Yes, yes, it's a service. Okay, we can utilize this their model endpoint. This is the they have developed this model, and we are using this endpoint. Okay, a Llama 3.1 8 billion install. This is the endpoint.
This is a kind of LLM or
Yeah, this is the LLM application. Okay, this is the model, and we are using through this API, right? This is the where we are using this chat grok is the API. Okay, in that API, we are passing these different models, and we are setting the different parameters. Okay, that's how we can easily utilize this models our local system also. Okay,
okay.
so now this is the clear, right? Till now. So
Yeah.
let me create this API key for this Google Studio. Okay, guys. So here you can see this is the studio. How do we can get here? So you have to click here, type the Google Gemini API key, and here guys see Google AI Studio. Okay, click on this Google AI Studio. Okay, and then we have to create this API key. Okay, so here click on this API key. Okay, they will ask for this project. Okay, this my project. I will be creating this. Okay, my project. Create API key. Okay, it is generating the key. And guys, whenever this key is created, we have to copy and paste. Okay, then otherwise we cannot reuse this key. Okay, we have to copy, go here, and then .env file. Okay, .env file, what I'll do, this is my Gemini API key. Okay, this is the Gemini API key. I will be storing here. Okay, okay, perfect. Now we are good to go ahead. Okay, so now we can close this also, not an issue. We have already copy this, right? We can close this. Okay, we have already copied. Okay, you can see I have created this key. Then what is the next step? We have to get started with the coding. Okay, so this is the app, Gemini app. So here guys see what I'll do, this is the same code, right? So here we are using this load environment. Here just only change is the Google Generative AI we are using here, and then loading the environment as like previous one. Okay, this is my API key. So this is my API key. We can give any variable now name. Okay, Gemini API key or API key, that is not an issue. But this environment name, okay, this environment name should be the same. Okay, here you can see this is the environment name as the this one Gemini API key. So this environment names should be same here. We are calling here while calling. So here I need to pass here like this one only. Okay. So why I am like writing this one? Because I have written this name as a small letters. If you write written in the capital letters, you can use the capital letters here. If you written in the small letter, you can use the small letter. That is not an issue. Okay. So here Gemini API key. Okay. Then next step is to, let's suppose we have to define the model. Okay, guys. What is the next step? Define model. How do we define the model? Let's suppose the model equal to GenAI dot generative generative model, generative model. Okay. In the generative models, we are using these different models. Okay, guys. So here, if you go here, they have provided these different models. Okay. So let me check the different models, Gemini models. Okay, so here you can see what are the different models we are going to use. So they have provided here different models. Okay, so here guys see Gemini. Now this is the 2.5 also new models, 2.0 flash models, 2.0 flash light models. Okay, these are the different models. Okay, you can see and they have provided these models, different model variants. This is the input. Okay, how which models taking the which input. Okay, let's suppose this is the Gemini 2.4 preview models. Okay, so this will take the audio as input, this will take input as a images also, videos also, and text also, and it will return the output as a text. Okay, what purpose they have used? Enhance the thinking and reasoning, multimodal understanding, the advanced coding, and more. Okay, then we are using this flash. Okay, flash 0.2 models. This is also multimodal, image, audio, and text we can pass as input. Then we are getting this text, image, and audio as a output. Okay, this is the audio as a coming soon, and images as a experimental. Okay, and this is the next generation feature: speed thinking, real time streaming, multimodal generation. Okay, so these are the different model guys. Okay, this flash model is light is there for this audio, image, audio. This is also multi-model. Okay, then we are using this Gemini embedding models. Okay, this is for the embedding purpose. This is the Gemini embedding experimental. These are the embedding purpose. And here guys see Gemini Pro is there, 1.4 model is there. We are utilizing this Pro models. Okay, flash model is there, Gemini flash models. Okay, this is the model card. Okay, this is the this is the model name, this is the input, this is the output. What is the input tokens? We are passing this 1 million token input. Then output size is the 8,000 k tokens. Then maximum number of images per prompt, it will generate the 3,600. Maximum video length, it will take as a 1 hour length video it will generate. Okay, so these are the different model cards. Okay, they have provided what is the supported models, what are the instruction. Okay, the versions of these different models. Okay, so you can go through this. Okay, guys, I will provide in this link also. You can go and read it. Okay, different models. So this is the different. Okay, different models. Gemini model variants. Okay, model variants. Okay, so these are the different variants of these Gemini models. Now we are using this. Let's suppose Gemini 1.5 Pro, or we can use this Gemini 2.0 model. Okay, so here guys see 1.5 flash is there. This is the 1.5. Okay, I am using this Gemini 1.5 Pro. Okay, this is the experimental, our most advanced Gemini model. Gemini Endpoint is the mid-size multi-model. Okay, optimized for the wide range of reasoning tasks. 1.0 Pro can access the large amount of data at once, including 2 hours of video, 19 hours of audio, a code base of 16,000 line of code, and 2,000 pages text. Okay, it will.
Like 1 hour.
I am using this model. Okay, Gemini 1.5 Pro models.
Actually, 1 hour.
So model equal to this Gemini 1.5 Pro model. Okay, and then we have to set this UI, right? Set this streamlit UI. Okay, so here guys, st dot set page. Okay, set page config, set page config. Okay, this is the, it will set the, it will create the page guys. Okay, st dot. Okay, it will create the page config, and then we are setting this title. Okay, st dot title, title. And here in the title, let me write like this: ask me anything. Okay, ask me anything. Okay, perfect. So this how we have created a small application, guys. Okay, this just the title I have added. Okay, now we can run this application. How to run this application, guys? Let me Okay. Okay. Here what we have to do? Streamlit. Okay. Streamlit. Run. What is the file name, guys? App underscore Gemini, right? App underscore Gemini dot py. Okay. So you can see I am running this application. Okay, you can see it is running up and running. So it will show only the title. Okay, it will show the title. Other functionality we have not added till now. Okay, you can see ask me anything. We got this only application like this. Now I will be adding this functionality into it. Okay. So here now user input. Okay. So user input, I will be passing this user input text input. Okay, text input as a st dot text input. Okay, text area, or you can use the input also. Okay, I will show the difference between them. Okay, text input and text area. Okay, so label equal to, let's suppose label, label equal to, enter your enter your query, or we can say prompt here. Okay, you can say enter your query here. Okay, this is my instruction here, and here what will I do? Let me just save this. Okay, then go back to this UI, rerun this. Okay, now guys, see, I got this input. Okay, enter your query here. I got this as a text area. This is the text input. Okay, but let's suppose I am using the, instead of this text input, I will use the text area. It will give the more space. Okay, guys, it will give the more space. Okay, instead of text input, we using the text area. Okay, text area. So if you check here, what is the difference between them? It will give in the more space. Okay, so you can see, guys, this is the pace is more. Okay, whenever you want the pace more, in that case we can use the text area. Okay, but whenever you want to less space, okay, whenever you want the less space, we can use this text input. Okay, that is the only difference. I hope this is clear, guys. You can see, rerun it, it will show the small pace. Okay, like this. Perfect. Now this is the next step. Is what is the next step? So we have to use the submit button. Okay, we have to use the submit button. This is my submit button. st dot button. Okay, st dot button. Okay, guys, so guys, this is the streamlit. Okay, I will be you have to go through the right documentation of streamlit. There are the multiple functionality. Okay, this is the submit button. Okay, submit as a label as a submit, then check here, it is a, okay, you can see rerun this. You can see submit button is there, right? We got the submit button. So here, guys, see, you have to see the different functionality, right? Streamlit documentation, you have to go into streamlit documentation. Okay, and you have to refer this documentation. Okay, guys, so if you, these are the fundamental concept. Okay, this is the fundamental concept, we can get started from this. Okay, fundamentals. This is the installation. How do we install it? We install streamlit. Okay, or streamlit hello, it will show the basic code. Okay, then we can use this, how do we can use the command line? Then you can use this github anaconda. Okay, then you can click on this fundamentals. Okay, basic concept. Okay, you can see the basic concept, you can go through this. Okay, python yum, or you can use the streamlit run. Okay, I'm using utilizing this streamlit run and this script.py. You can also run, utilize this python hyphen yum machine streamlit run your script like this. Okay, and it will run like this also. Okay, if you want to run this github dist, you can pass this github also, github file also dot api, you can directly run. Okay, in the, if let's suppose this is the github url. Okay, guys, github burst streamlit demo, and there is some application, streamlit application is file is there, streamlit app.py, you can run directly. Okay, the github file also. So then we can go through this basic. Okay, this is the basic program. Okay, in the streamlit application they have created this basic program. It has created this data frame, and we are going to see in the data frame the UI also. Okay, so I will showcase this basic also after this, so that you can have this idea about this. Okay, what are the basics of this streamlit application? So Yeah, ask me anything. Hi. Submit button. It will not show any output. Okay, guys. It will not show you because we are not call any LLM. Okay. Now we are going to call this LLM. Just we have initialized. Okay, guys. Here we have just initialized this model. Now we have to call this model when the question asks. Okay. So submit button we have created. If submit button. Okay. If submit button. In the submit button, what we are doing? The response equal to the model dot generate content. Okay, generate content, and then we are passing this text input. Okay, guys, text input, we are passing this text input, nothing but the user query. Okay, here we are passing this user query to the model. Okay, model will generate the response. Okay, from this, and then we are writing this. Okay, so guys, see here, I have just get the response. Okay, now we can see rerun. Okay, hi. Okay, I'm clicking this high. Okay, but here guys, see, it is running. Okay, it is showing the running. Okay, it is running. How many times? Okay, we are getting this no API key found. Okay, so Google API key. Okay, it is not getting this KPI key found. Let me change this. Okay, API Google API key and then pass this key. Okay, let me check what happened. This is the environment variable. Okay, in the environment variable, let me change the name as a this one, Google API key. Let's save this. Okay, then in this here also I need to change the name. Okay, this is the Google API key. Let's save this. Let's try again. Rerun.
No change again.
No API key, or please enter the set Google API environment variable, manually pass this key. Okay.
Wait, you not change on the folder.
Sorry.
I said on the folder, you still left it as Gemini API keys.
Yeah, Gemini API key is right.
So maybe you edit it there and let's see again.
What
No,
happened? Let me check.
on the Visual Studio Code. You
You
have the
just
API Gemini.
here Gemini
Yeah.
API key like this. So it will not means it will not show any error actually. Okay, you can write as a Google API key also. That is not an issue. Okay, Google API key. Okay, Google
You
API
can give
key.
a command under that you can run on the terminal to correct that.
Command line. Let me check, guys. One second. Google API key. This is my Google API key. Let me check this. Okay, this is not setting up. Okay. Load environment is also there. Okay, load environment is also there. And then we have this OS.
Man, create an application. Excuse my main, it's your project.
Just 1 second, guys. I will be.
Class nine.
Let's try this. Okay, if not, we can set this Google Gemini key by directly. Manually also we can.
Okay, I don't class. Now like class 170. Class is due during 2 months.
Genia.config.
Almost 2 months. Mbolo yung Avis,
Avis. Equal to my
the next one still okay. Martin, since you link.
Let's try this. Okay, Genia.config. Okay, Genia.config. Okay, generative.config, and this is my API key. Okay, let's try this way. If this possible, then let's try it out.
Oh,
Okay.
the generated, yeah.
The fucking no. The
Okay, let me rerun this.
Can you see under there where that error message is?
deep
There's a
science.
code that is
Guys, please be on mute. Okay, guys, if you are not talking, just please on mute.
Yes, Ajay.
Yes.
I was saying that the page you just opened, there's a code that they gave us there, which we can use to correct that.
Oh, sorry, can you come again? What was?
On that page that you just came out from, there is a code that they gave that you can use on the command line to correct whatever is happening there.
Yes, yes, yes. What I can do, guys, I can use this. Okay, I can set this environment variable through command line also. Okay, but here, let me try this way. If not set, I will try it out the command line. Okay, simply run this Gemini API key. Okay, let's give a try. If not, then we can figure it out how we can set up this okay environment. Okay, it is not getting response. Okay, why it is not getting response? Okay. Uh, okay, guys. Okay, now it is not getting any error. Okay, now we can write this. Okay, st.write. Okay, we have to write this, right? We can get the response as a response dot content. Response dot content. Okay, so response dot text. Okay, we can use this text here. Okay, perfect. Now you can see, guys. Now what happened? Okay, we are rerunning it. Okay, rerun it, submit it, and we are getting this response here. Okay, we are getting hi there, how can I help it today? So here, guys, we have to just add one line. Okay, so one line was there. We have to just, whenever you are using this GenAI, we have to use this genia.configure API key equal to API key. Okay, that is only line. That's why we are getting error. I have set this line and we are now good to proceed further. Okay, so here, guys, see, if you ask, okay, so let me submit. After this submit, yeah, we got the response, right? So here we can ask this. Let me, what is Azure AI Studio? Okay, Azure AI Studio. Okay, so let me ask this question. So we will get the response. Okay, we will get the response. Okay, you can see, guys, we are getting the response. Okay, Azure AI Studio is the web bus development for this building, training, and deploying the machine learning models. Okay, so for that purpose, we are using this Azure AI Studio also. So here we have different compute services. Then we have this data management, deployment. Okay, model deployment manager, responsible AI. All these are the different features of this Azure AI Studio. Okay, so this how, guys, we can utilize this, right? We saw, right, how we can utilize this Gemini models, how we can utilize this Llama models. Okay, through this chart group API, and from this Streamlit application also, from this Gemini also, right? Gemini models also we saw. Let's suppose we want to try the different models, right? For that purpose, we can go ahead and try out different version. Okay, this Flash model also we can try it out. Okay, this is the very fast model, Gemini. Okay, Flash model. I don't know. I have access or not. Let's try it out. Okay. So this is the 1.5 Pro models. Okay. Next time what I'll do, I will utilize this model. Yeah, Gemini Flash model. Okay. This is the very fast model. Okay, compared to this 1.4. Here, let me rerun this my script. Rerun. Okay. And so, okay, guys, you can see this is a very fast model. Okay, this flash model is very fast model. Okay, we can use like a means generative. It is explaining, right, what is this text, images, all this. Okay, it is explaining. So here we can try it out different model. Okay, this is the flash model. Let's suppose I want to use this flash light model also. Okay, you can use this light model also. Just try it out. Okay, guys. I will be keeping for this for you to experiment. Okay, I will keep in this for this your experiment. You can try it out. This different models. Okay, this flash model, Gemini, this 2.0 flash model. Okay, 2.0 flash model. Okay, perfect. Then we have this 2.5 preview model. Okay, this is the preview models. This is the paid model. Okay, I see. This is the paid model we cannot use. Okay, this Gemini 2.5 model we cannot use. You can use, but we have to require the paid. Okay, then we can try this. As of now, experiment person, just try it out. I do not suggest go for the payment. Okay, just try it out. This available model. Okay, this whatever the available model is there, just utilize this model. Okay, and whenever is required in the industry, this industry will provide this. Okay, models for you, paid versions. This is the another models. Okay, Gemini Flash models. Okay, then 1.5 Pro we saw. Then we have this image gen. Okay, this image gen is for the our highest quality text to image. Okay, guys, whenever we want to use text to image model, in that case we can use this image gen 3 model. Okay, so this model also we can utilize. Okay, so this is the task for you guys. Okay, so utilize this model also. Okay, image gen 3 also. So I will be keeping the exercise for you guys. Okay, just utilize these models. Just copy, and I will be pasting here in the this notebook. Okay, so this is my requirement file, and this is my app.py file. Okay, app Gemini.py file. Okay, so this is my py file. Okay, guys, see here. So this is the code. Okay, so you have to set this environment key and just utilize this different models. Okay, and now we saw, right, the simple models. Okay, using the uh, this open source model, right, chart graph. We can leverage these different models from the chart graph. Okay, and guys, for the interview purpose, if you are preparing for this interview, they will ask, right, what are the models you tried. So you tried it out. Okay, these are the different models, you can try it out, and they will ask question, what are the different models you tried out and which one is working well. Okay, so we have to try it out, these different models, open source models. And then paid models are like OpenAI. We know, right, we have used this OpenAI, but as of now I'm not going for this OpenAI. We already see how we can utilize this OpenAI. This is the paid version, but this is the free version. We can utilize this different models. Okay, so you can say initially we started for this. I will explain the project explanation in that. Okay, we have to say initially we have utilize this different open source model from the chart Grok API, and also from this Gemini we have utilized these models for experiment purpose. And then as per the company norms, we have go for this Gemini models. Okay, they have provided access to Gemini models paid version, and we have utilized this Gemini 1.5, 1.5 Pro 2. Okay, these are the different models we can utilize for this our experiment purpose. Okay, so this is the very simple model. Let me build a RAG based application. Okay, now I will be building the RAG based application where we are passing this our data. Okay, so let me, what I can do, let me stop this. Okay, I'm stopping this application. uh, Let me create this one of the application as a RAG based application. Okay, so RAG, I am using the, let's suppose, okay, RAG ragapp.py. Okay, so guys, see, I'm using the RAG application now. Okay, so here I am creating the RAG-based application. RAG-based application nothing but we are passing our own data, and based upon this own data, we are getting the response. Okay, so we are getting the response. Okay, so how do we can create this RAG-based application? So we require to update our requirement files. Okay, let's try it out. Import OS. This is the things I think we are required here. Okay, yeah, import OS. Then let me import directly from here some of the basic files. Okay, these are the basic things we need to import from this. Keep here my okay guys, this is very important. Keep concentrate here. Okay, so then we can use this langchain dot document loader. Okay, from langchain dot document loader document underscore loaders import PyPDF. Okay, as of now I am using the PyPDF. Okay, but going further, there are the different loaders also. I will be showing you. Okay, in the next project. So from langchain dot document. What happened? Okay, that is not an issue. Langchain. If you have any question, guys, just ask. Okay, if you have any question, just ask it. Langchain dot. We are using this text splitter. Okay, text splitter. Why we are using this text splitter, guys? Anyone can tell me? Anyone can tell me why we are using this splitter? What is the necessity of the splitting the text?
For churning.
Yeah, chunking purpose, right? Why chunking is required?
Pardon me?
Yes, tell me.
I said for chunking.
Yes, yes. And why chunking is important? Why we are doing the chunking?
Embedding.
For easy
To get this
easy,
specific
search scalability.
Guys, okay, and just revise this. Okay, this is very important. Okay, yesterday's session, what I did. So why we are doing this chunking? Because the chunking it will split the document into the small chunk, right? For the efficient search and efficient
Search and
retrieval
efficiency.
purpose, right?
Yeah,
That is the answer for this question. Okay.
for easy search and efficiency. Okay.
Yeah. For because and it also having this limitation. Okay, let's suppose let me show the limitation. Okay, so let's go to this grok API. Okay, so here guys see this is the context windows. Why we are doing the chunking? But for this window, okay, let's suppose I am utilizing this model. Okay, let's suppose this model llama 3 billion. Okay, this is the model I am utilizing. This model in accept the window size of 8,000 token only. Okay, this model is accepting only 8,000 token as input, and we are passing the whole document, whole PDF to the input. It will not, okay, it will showing the error because it will not able to handle this all the tokens. Okay, it is a limited only 8,000 token. So and below this 8,000 token we have to chunk. Okay, so that we can pass only one by one chunk to the model, because we have the context window as a some of the 8,000, but some of the models having this context window as higher, then we don't have any issue. But some of the models, okay, these are the models we have the issue. We cannot pass this whole document as an input. Okay, because this limitation of this input context window tokens. Okay, input token limit of this model, it will process only 8,000 token at a time. Okay, some of the model is processing the 120k 28k tokens at a time, but these are the models, some of the models handling only 8,000 token as input. That's why we are required this chunking for this context window limitation, as well as this efficient retrieval, efficient search purpose. These are the three reasons why we are doing the chunking. Okay, so they will ask you why we are doing the chunking. Okay, that is the reason you have to explain in the interview. Okay, then we are using vector database. Why we are using the vector database, guys? Anyone tell me?
For embedding.
Store the embedding, right? Store the embedding. Yeah. So and why embedding? So we are using embedding models.
Yeah.
Create the vectors, right?
Yeah, for vector database.
Yeah, this embedding models we are using for the embedding purpose, right? Creating for the vector purpose. And this vector store, we are storing this created embeddings, right? So here I say langchain dot embeddings. I am utilizing this Hugging Face embedding. Okay, we saw OpenAI embedding also, but that is the paid version. Now I am using this open source Hugging Face embedding. Then import langchain dot embedding. And then Hugging Face, we are importing this Hugging Face embedding model. Okay, Hugging Face. Hugging Face embedding. Okay, Hugging Face embedding. Okay, Hugging Face embedding model. Okay, so then we are using this vector store, right? We are using the vector store in memory. Okay, in memory vector store we are using as of now. Vector store, vector stores, langchain dot vector stores import files. Okay, we are using the files database. We saw ChromaDB also, right? In last session we saw ChromaDB also, but now we are using this. These are the local database. Okay, files and uh, this ChromaDB, right? These are the local databases, and this is the FIS is the in memory and faster inference. Okay, it will provide the faster inference, and this is the in memory. Okay, it will store this document in memory. Okay, in the text. Okay, for the small application we can use this FIS and ChromaDB. Okay, but large application we can ChromaDB also use we can use for the large application. Okay, but FIS is for the in memory. It will store this locally and in memory. Disguise will be memory disguise. Okay, so langchain.vector store as a files. Okay, then what we are using, then chartbox already utilized. So guys, I will be utilizing this buffer memory. Okay, why we are using the memory, guys? What purpose we are using this memory? To store this data, right? Previous conversation. So for that purpose we are using this memory langchain dot memory. We are import this conversation buffer memory. Okay, so it will return this previous conversation. Okay, guys, conversation buffer memory. Okay, it is a import this conversation buffer memory from this langchain. Okay, it will return, and then we have to use this retrieval chain, right? Question answer retrieval chain required, no? Langchain dot chain. We are importing this conversation conversational retrieval. Okay, retrieval chain. Okay, we already use, guys. Okay, this all this we have already viewed. Just I am creating one application. Okay, already I have used this. Okay, then what is the next step? We have to load the environment. How do we load this environment, guys? So with the help of this. Okay, let me copy this. I am using the grok API. Okay, so I use the grok API here. This is the rag app. So how do we load this environment? So load this .env, and then we have to use this grok API key. Okay, guys. So .env already we have imported. Now we are loading this environment, and from this environment variable we are getting this grok API key. Okay, this is my first step. Okay,
Embed.
yeah, and then no, we have to load this, right? We have to read the data, split, chunking, embedding. Then we can use the streamlit. Okay, at the last.
All right.
Yeah. Then we can set the working directory, guys. We are setting this working directory. Working directory. Okay, so here working directory, working dir, working directory equal to, this is the OS dot path dot directory name. Okay, directory name, then OS dot path dot absolute path. Okay, absolute path, and this is my underscore file. What are the files? I will get the access to this file. Okay, from this. Okay, files. Okay, perfect. I have set this working directory. This is my working directory. Okay, guys, this is my working directory. Just I have initialize this working directory. Okay, and if you don't want, you can remove this working directory. But for this example, I have kept here so that I can store this file in whenever I get this file. I will explain why we are using this. Okay, then here we are loading the document. What is the first step, guys?
Split.
Load the document. Without load, how do we can split?
Yeah, we need to load and then split.
Yeah. So here we have to define the function, guys. Okay. In the industry, we have to define the modular code. Okay. So load documents, and here I will take in the file. Okay, file path. Okay, this is my file path, and then what I'll do. So this is my file paths. Okay. And from this file path, let's suppose all document I will be storing all this document in the list. Okay, all this document in the list I will be storing in the list. Okay, and for file, okay, file path in file path. Okay, in file paths. Okay, I will iterating, guys. Okay, so this is my file path. I will be providing file path, and in that file path I am iterating each of the file path. Okay, I will be iterating each of the file path. Okay, and then I am using the loaders. Okay, I am using the loader equal to py-pdf. Okay, so we require to install this py-pdf. Okay, py-pdf loader. Okay, this is the py-pdf loader, and we are passing this file path. Okay, we are passing this different file path, and we are loading this with the help of file path. Then documents equal to loader dot, what is the method, guys?
Read.
Load. Yeah. Then what we are, once this document is loaded, right? We saw in the yesterday session, we are loading the document. Now this loaded document I will be storing in the list. How do I store in the list? Append and extend, right? So we can extend. Extend means it will just appending this document. Okay, whatever the document we are getting, just we are appending, we are storing in this this list. Okay, all document dot extend. We are passing these documents. Okay, perfect. So this how we have loaded this document, and then we have to return something. Okay, we have to return this list. Okay, so this list will be, I will be returning. Okay, this is clear, guys, how we are storing. Okay, how we are reading this document, and how we are loading, and how we are storing in the list. Okay, this is the for this loading the document and storing in the list. Okay, this is the first function. Then let's suppose I want to use the vector store. Okay, guys, vector store, set up the vector store. Okay, and before set up the vector store, I need to do the chunking. Okay, guys, I need to do the chunking. Okay, chunking I will do. Let's suppose I will make the chunking. Okay, how do we make the chunking, guys? Can anyone tell me? Text splitter. This is the text splitter. Here, what we are using, the text splitter dot split document. Okay, split documents. Okay, split documents. And in the documents we are passing this documents. Okay, these are the documents. Okay, these are the documents we are passing here in the split document. Text splitter. This is how I am setting this text splitter. Okay, I have defined this text splitter now. Yes, yeah, this character text splitter. Okay, character text splitter. From this, okay, I need to define this character text splitter. Okay, let me define this character text splitter. Okay, character text splitter, and then utilizing the, let me, okay, in the characters text splitter. Okay, this is the character text splitter. In the text splitter, we are using the separator. Okay, guys, by default it is the separate this split the by default on the new line. Okay, so new line, how do we create the new line? Backslash
N.
n. Okay, this is the separator. And then chunk size, what is the chunk size?
8,000.
Okay, so we can give, let's suppose 1000 as a chunk size. Okay, and this chunk, oh, why we are using the chunk overlap size, guys? Anyone tell me?
To get the accurate results. I mean, accurate search results. In case.
Okay, whenever we are splitting, the split data will be splitting, right? In between the sentences, in between the paragraph, right? Some of the half of the sentence will come in the first chunk sentence, half of the sentence will come in the second chunk. So for that overlap purpose, to keep the semantic meaning, capture the semantic meaning, we are utilizing this overlap of the chunk, right? For the better accuracy in all this, better capture the semantic meaning. Okay. So this is my text splitter. Okay, understood, guys? This is the text splitter, and this text splitter I will be utilizing for this document loading, right? Text splitter equal to, okay, text splitter dot split document. Okay, split. Okay, text underscore splitter, text underscore splitter dot split documents. Okay, split underscore documents, split underscore document, and then we are using this. We are passing some documents. Okay, we are passing some of the documents here. Okay, we are yesterday we passed this document. Okay, so now let's suppose I am passing this document. I need to define the document initially. Okay, this is the documents. Okay, perfect. This is the chunking. Okay, guys. So after the chunking, what is the next step? What is the next step, guys?
Embedding.
Embedding, right? So here I will be embedding, use this embedding. Okay, embedding is equal to Hugging Face embedding I am utilizing. Okay, Hugging Face embedding. Okay, and the model name is, what is the model name yesterday we saw? Sentence transformer, right, guys?
Yeah, transformers.
And they will ask you which model we tried out. We have to tell we have tried OpenAI embedding, ADA series model, and this is the my Hugging Face sentence transformer model. Okay, sentence transformer. Okay, this is the transformer model, and I am using this all mini. Okay, all mini ALM L6 version 2. Okay, version 2. Okay, so this is the sentence transformer. Okay, sentence transformer all mini LM L6 version V2. Okay, this is the my Hugging Face embedding models. Okay, and then after this, what is the next step, guys?
Context.
We have to store this, right? Vector store, right? We have to define the
Vector store.
Yeah.
Vector database.
Vector database, correct. Vector store. Okay, vector database, or we can say vector store. Okay, so here I am utilizing this, let's suppose vector store equal to, I am utilizing which database here, guys? FIS. What is the FIS?
FIS is in memory and lightweight, faster accessible.
Correct. So it is the in-memory database. It is the faster inference. Okay, it is optimized for the in-memory. And from these documents, okay, file.documents, from documents, we are passing this chunk document. We are passing this chunk document, right? Chunk documents, and it's embedding, right? So let's suppose I am passing this document chunk. Okay, and it's embedding. Okay, embedding models also we are passing this embedding models in while the creating the vector store. Okay, okay. Till now clear, guys? Any questions so far? Okay, so can I write this into the function, one of the function, these three things after the loading, after this loading, which is chunking, this embedding and vector store, can I write in the one function?
Yeah.
Okay, let me write one function. Define setup vector store. Okay, setup vector store. I'm writing this in just, these are the only steps I will be writing in the function. Okay, this is the, we have to create the modular code, guys. Okay, in the industry we do not write like this. Okay, like this we have to create this code as a modular, okay, in the function form. Okay, so that we can reuse this code, okay, again and again. So underscore document. So I will be utilizing this. Okay, guys, I will be utilizing this lines here. The same lines I will be passing here in this function. Okay, I will not doing any changes. Just what I'll doing, just I will keeping the inside this function. Okay, this is the embedding models. Then I have this text splitter. Okay, let's suppose this is my text splitter. Initially we can pass this. Yeah.
And then
This is the
embedding,
chunk,
and
then embedding, and then vector store.
vector store.
Vector store. Okay, this is the embedding. This is the vector store. This is the chunking models. Okay. So I hope this is clear till now, guys. Anyone have any question? Just ask. Okay. And here, guys, what I'll do. Okay. This split documents. Okay. Document splitter we saw. And here I will be storing this. Okay, into some of the variables. Okay. Document splitter. I will be storing this doc underscore chunk. Okay, doc underscore chunks equal to this. I am just storing, okay, this I'm just storing into the some of the variables as a doc underscore chunks. Okay, and then after this chunking I have defined this embedding models and this is vector store. Okay, and then what I'll do, I will return something, right? What's the end of this? What will I return? Tell me.
Vector store.
Vector store, right? End result we have to store, right? Vector store. So here guys, see what I did. I have loaded document, then I split it. Okay, I will pass here document. It will split this document. Okay, and then it will chunk this document. This embedding, we are doing this embedding with the help of this embedding model, and then we are vector storing. Okay, and then we are written this vector store as the end result of this process. Okay, so this is the second function we have completed. Then this is the last function as a, but create the chain. Okay, guys, we have to create the chains. Okay, so here let me write this different like LLM model. Okay, okay, so directly I can write it. Now you can understand what is the modular code. Okay, create underscore chain. Okay, and then we are passing this vector store, vector store. Okay, this is my vector store. And then in the vector store, let's suppose I am define this LLM model. Okay, guys. So LLM model I can define outside this also or inside this also. That is not an issue. Okay, we can define this LLM model. Let's suppose I will define this model outside this also. That is not an issue. Outside this function, or we can define inside that function is not an issue. Okay. So let me define the here LLM model equal to, see the chart graph. Okay, chart graph model. In this model, we are passing this model equal to, which model we can use, guys? Llama.
Transform. Yeah.
Llama model. Okay, this is the chart graph. Okay, we are using the chart graph. We are using the versatile model. Okay, this is versatile model. We are using it. Or we can use this different model also. But for now, just I am utilizing this model as a versatile 3.3 70 billion parameters. Okay, and let's try it out. This is the model. In this model, what are the other parameter I can pass? Temperature and top P, right? What is the temperature, guys? Tell me. Why we are setting
0.1.
0 and 1. 1 is for the
0.1.
creative.
Okay. 0.1 means
Accurate. 0.1 is for the
Deterministic.
accurate.
deterministic, right? It is close to 0. Means it will not. It will deterministic. It will not randomness. It in the answer. It will not in the randomness in the answer. It will more deterministic, close to 0. And what is the top P?
The top P should be 0.9.
Yeah, correct. Why 0.9?
We want the best, the next, the word with the highest probability
Yeah.
to, yeah.
Correct. So guys, here we have the lots of, right? We have the vocabulary, right? We saw, right, this top P, K. Just revise, guys. Okay. So here we have the vocabulary, right? And in the vocabulary, this LLM model will be utilize the softmax and okay, and it will predict the, let's suppose in the vocabulary we have the 30k words, okay, 30k words, okay. Let's suppose we have the 30k words and we are passing this softmax, and softmax will provide this 30k probability, okay, 30k probability will provide. But what we are doing, we are selecting, okay, it will provide the 30k probability. Out of this 30k probability, we are selecting the probability of those words, its cumulative sum of 0.9, okay. So we are selecting the words, select the top n words, okay, n words whose, okay, whose cumulative, okay, whose cumulative probability sum, okay, cumulative probability sum, which is probability sum, okay, you can say, let's suppose probability sum, probability probability sums sum to this number, okay, this number top p. Okay, got this point now. So let's suppose I'm passing this vocab size is 30k, lots of, it may be anything, okay. For this LLM model has this lots of billions of parameters, okay. It is trained on the billions of parameters. I'm example for taking the 30k tokens, okay, 30k words as my vocabulary, and it will softness will predict this probability for each of the words. Who will be my next candidate? I will be predicting the probability for each of the words, and from that, what I'll do, I will take the top n words whose probability is 0.9, okay, top n words whose probability sum is 0.9. Let's suppose I am taking the 0.95. So let's suppose here I am taking the point, let's suppose initially 9, okay, 0.9. So here I will, let's suppose I getting the three words, okay, I am getting only three words, okay, three words, okay, I'm getting the three words whose probability sum is getting as a 0.9. Then I will take only three words for the next probable candidate. Out of these three words, I will be taking the next probable candidate. Let's suppose I am taking the probability value as a 0.95. Then I will, let's suppose for this 95 I am getting only, where it is, where it is, yeah, so 0.95 probability I am getting, let's suppose only two words, okay, 1 5, okay, 0.95 probability I am getting only two words, okay, two words. Out of these two words I will be predicting the next word, okay. These are the two words will be the my candidate probable candidates words, and out of that I will be taking these words to make the next prediction, okay. I hope this is clear now, guys, why we are taking this top pick. It will select the words and those having this probability sum as a 0.95, means 95%, those words coming from this next word is coming from this 0.95, okay. So here we can take this one also, okay. Then it should be top it should be the close to one, because we are taking this probability value from this probable candidates words, okay, whose sum is 0.9, 0.95. I am taking as a 9 here. So I am collecting those words whose some probability sum is coming at 9, and from this words I will be finding my next word, okay, like this. Then we are storing this, we are passing this vector store in the create chain, okay. In the create chain we are passing this, and then we are setting this, what is the, we are set up this vector store retrieval, right? How do you set up the retrieval, guys? Anyone can tell me? We saw, right, vector store as a retriever, right? Vector store as a yesterday's class, that's why I taken this, right, to introduce your different component of this, okay, RAG architecture. Now we are able to get it simply, okay. Vector store as a vector retriever, okay. Then what is the next step? Memory, right? We have to add this memory so that it will store this previous conversation, okay. Memory, we are using the conversational memory, okay, conversational buffer memory, okay, conversational buffer memory, okay. It will store this previous conversation, okay. So here we are passing this memory key, okay. This is the memory key equal to, this is the chart history, okay, chart history, Okay, and from this charge history, we are returning? We have to return the message also. Okay, return message. Message is equal to true. Okay, it will return the messages also. Okay, so it is the first. Okay, like this. And this is how we have set up the memory. We have written the retriever also. Okay, then we have set up this memory. And after this memory, what is the next step is chain equal to conversational retrieval chain. Okay, in the conversational retrieval chain, what we are doing guys? Here from LLM, we are passing this LLM equal to LLM, then retriever equal to retriever, right? Retriever. What's the next step? Memory, right? We are also adding this memory for the conversation purpose. Okay, guys, to store this previous, right, history. And then we are using this verbose equal to true. Verbose equal to true means it will showcase the
Log.
logs. Okay, logs. Verbose equal to true. Okay, this is how we have set up this chain. Okay, now we have set up the chain. And what is the what will we are return back? What is the output of this?
When you, excuse me, please.
Yes.
When you wrote verbose equal to true, would that mean that what does that supposed to mean? Let me know, guess.
Yeah, it's a show the logs. Okay, you can see here logs. Okay, whenever it will run, it will show the logs we saw previously also. If you remove this, it will not show the logs here. Okay.
Okay.
Okay. Yeah, for that purpose we are using. You can remove this. This is not a required in the production. Okay, we can remove this. Okay, but if I'm I am keeping here. You can see the how this LLM is working. Okay, step by step. For that purpose, just I have keep it. We can remove this. Okay, not an issue. And then what is the end objective of this function? What we are going to return? Tell me guys. Chain, right? At the last, we are returning this chain because we have set up this vector, set up this memory, and at the last, we are utilizing this chain, okay, as a end result of this function, okay, we are returning. So now we can set up this UI, okay, streamlit UI. We application is built, guys, okay, now application is built, okay, and then we have to set up this UI, streamlit UI, okay, streamlit app UI, okay. So here setup dot set page config, set page config. Okay, so here in the page config, let's suppose I am passing the different parameter. Let's suppose page title. Okay, page title as a chart with PDF. Okay, chart with PDF. Okay, this is my PDF. Then let's suppose the page layout. Okay, page layout. Okay, guys. So let's suppose page layout. My page layout. Okay, in the page layout, I will be icon. Okay, page icon. I can pass. Okay, one of the symbols. Okay, suppose page icon. Okay, page icon. I will be passing the icon of page. Okay, so how do I get the page icon? You can click here. Okay, emoji DB. Okay, emoji DB. Okay, click on emoji DB. So here these are the different emoji guys. Okay, so here I want to find this file. Okay, page icon. Okay, page icon. So guys, see this is my page icon. I will be utilizing this one, or I will be utilizing this one. Okay, just copy here, come here, and just paste here. Okay, this is my page icon. Okay, and then layout. I will be utilizing this layout. Okay, page layout is a center. Okay, this is my center. Okay, this is my center layout. It will show in the center. Okay, so now let's run this application. Streamlit. Just I have just created this name. Okay, nothing else. Streamlit run. What is the name of this rag underscore? this app. Okay, it is running, guys. Okay, you can see it is running an app. It will showcase some errors. Okay, if there is errors, we have to rectify, debug these errors. Okay, so no models langchain dot loaders. Okay, so here we have to okay, let me check langchain dot document loader. Okay, langchain dot document loader is there. Langchain dot document loader. So there was a spelling mistake. Okay, langchain dot document loader. So now we can rerun it. No module langchain. Okay, langchain. We need to install it. Okay, langchain we need to install. Okay, here we can add this langchain. Okay, yeah, chain. Okay, this is the langchain. So this is my file. Okay, guys, this is my requirement file. How do we install this requirement file, guys? We can install like pip install langchain. Okay, we can do like this also. Okay, we can do it one by one also. Okay, guys, pip install. What happened? Where this matter? Okay, let it be. I will be creating this again. Okay, so here we can utilize this pip install langchain also. Okay, directly it is we can install pip install langchain. Okay, like this also we can install it. Okay, but instead of doing this, okay, what we are doing? So if we add this requirement here in this requirement file, and then we can run this pip install hyphen r requirement dot txt. Okay, so this is the industry practice. Okay, guys, this is the industry practice. We have to keep this all these files requirement in the requirement.txt, and then we have to run this requirement.txt. Okay, so it is installing. Okay, you can see it is getting installation. And when the installation is completed, it will not show the red. Okay, it will remove this red symbol. Okay, you can see once the installation is completed, it will remove this red sign. Okay, from this red underscore this, you can see there are some of the red or orange lines inside below this. Why it is? Because this package is not installed. But for this line we are not getting the red lines. Okay, why? Because it is a install, already we install we, but this langchain is not installed. Now it is getting installed. Once this install, it will remove this red lines. Okay, this orange lines from this. Guys, just I will not take much more time. Okay, I will be just I will finish it. Okay, I know this is too late. Here, guys, I need to just initialize this. Okay, Steamlit application. Okay, I will initialize meantime this Steamlit application. Or shall we, guys? We see tomorrow. What do you suggest?
No, finish the program. Just finish it so that you don't get confused.
Sorry.
Just finish it.
Okay, okay. We can finish it. Okay, so that we can try it out your end also. So guys, see this installation is completed. Now you can see once the installation is completed, you can see this langchain, now the red line is completely vanishes. Okay, because this is the not install initially, but now it's the install. Okay, so we can save this and go to this. Okay, UI again. No module launcher. We have to we have to run this script. This is the my this is the file name. Okay, streamlit run rag okay underscore this app.py. Okay, guys. Now we can see we have designed this small UI. Okay, small UI. And this is the name only. Okay, in that UI nothing is there. Only name of this file will be there. Okay, name of this application will be there. Okay. No module langchain community. Okay, so here, guys, we have to install this langchain community also. Okay, so we have to install this langchain community also. So let me install this langchain community. In the requirement.php, here I will pass in here langchain community. Okay, then store it and then run it. Okay, it is also showing right pip install this LangChain community. We can do it, or we can directly do it, or we can directly run this requirement.txt file. Okay.
But it can see extended loading again.
Okay. It's installing. Okay. Let's install this. And meantime, I will be writing this code. Okay. Let's try this. Write the code. Right. So here, what I do. So here, guys, see, I will be okay. Just 1 second. What I'll do after this, I will be set the title. Okay, for this st dot title. Okay, in the title, I will be passing this chart with PDF. Okay, chart with PDF. Okay, chart with PDF, and we are using this llama model. Okay, let's suppose llama model. Okay, using the llama model, and go here. Okay, just go here and just here type this search here llama model. Okay, you can see here this llama is there. Okay, just copy this llama, this, and just I will paste it here this symbol. Okay, for this llama. Okay, this is the llama symbol, and here you see it is still installing this package, and then we are what we are doing installing the charge history. Okay, so it is installed. Okay, guys, now let me run it. Okay, streamlit run this rack dot. Okay, you can see, guys, whatever I had given there, it is getting here only. Okay, llama chart with PDF llama. Okay, so if you change this UI and this different symbol also, we can get the different symbol also, right? We can pass this llama symbol also. Okay, I'm just keeping this one, or just let me take this, change this one. Okay, this one. And here, guys, see, now what in do I will do, I will initialize the chart history. Okay, let's suppose I want to initialize this chart history. Initialize the chart history. Okay, chart history. Okay, and if okay, this is the session state. Okay, guys, so this is the session state I will be utilizing chart history. Okay, chart history not in session state st dot session state session underscore state. Okay, if this chart history in the not in session state, I will be defining this session state as a null value. Okay, session state as a empty session state dot chart history chart underscore history. Okay, chart underscore history equal to this. Okay, this is the my empty file. Okay, guys, this is my chart history. I am storing the session state as a empty. As of now, initially whenever we don't have any empty list is there. Okay, initially we don't have any chart, but whenever we have this chart, it will store in this list. Okay, then file upload. Okay, we are uploading the file upload. So here uploaded file, we are going to upload file. Okay, uploaded files equal to st dot files. Okay, string dot file uploader. Okay, this is the file uploader, and here we are what we are doing, upload your upload your PDF files. Okay, here we are uploading, we are giving this message. Okay, upload your PDF file from the UI. Okay, upload your PDF files, and then we are passing this type as a we are just accepting the, as of now, just we are accepting the PDF. Okay, so for that purpose, just I will be keeping as a PDF. So the next project we are going to other than this PDF, okay, docs, text file also we are going to see. But for now, I'm just keeping this as a type equal to this PDF, okay, this PDF file. And here I see, let's suppose I want to pass the one PDF or multiple PDF. Okay, for it will by default it will accept the only one file. Okay, so and whenever we want to provide the multiple files, it will also we can keep the multiple file also option there. Okay, so where it is? Okay, so rerun this. Okay, you can see here we have added this. Okay, upload the PDF file. Okay, so just I am uploading this PDF file. Attention is all your need. This is my PDF file. Okay, you can see it is having this uploading and just it is uploaded PDF file. Other functionality we need to add also. Okay, so we have defined this other functionality here. Okay, we have defined this vector store all this, but we haven't called here. Okay, so we need to call this. Okay, this file is just uploaded. After the file uploaded, so guys see here. I want to upload the multiple files. I can what I do accept multiple files equal to true. Okay, so if I do this, I am able to upload the multiple files at the same time. Okay, so here you can see rerun it. Okay, so at the time I was able to upload this one file, but the same times I want to upload this multiple files. Okay, so this attention is all new. Okay, this is the one file, and let's suppose I want to this another. Okay, this another file also I want to. Okay, not okay, not many. Okay, this one. Okay, NVIDIA. Okay, these are the two files. Okay, these are the two PDF files I'm able to upload at the same time. Okay, so this how guys we can upload at a one time one PDF by default, but whenever we want to upload the multiple files at the same times, we can use this accept multiple files equal to true. Okay, till now any questions guys? Then if uploaded, okay, uploaded files equal to uploaded files, okay, then file path equal to this is my the empty list. Okay, as of now this is the empty list. Then for I will be checking, right, is this uploaded one file or multiple files. For that purpose I need to iterate, right? So uploaded file in uploaded multiple files, right? Uploaded files. Okay, so I will be iterating. Okay, I will be iterating each and every files of this uploaded files. Let's suppose I have uploaded multiple files, so there way I will be iterating through each of the files. Okay, uploaded file in uploaded files. Okay, then what I'll do, file
File
dot
paths.
yeah, file path. Okay, file underscore path equal to os dot path dot join. Okay, this is the working directory, and this is the uploaded file. Okay, uploaded file, uploaded file. Okay, uploaded file dot name. Okay, uploaded file dot name. Okay, see here guys, now I have the okay, then what I'll do, I will be with open, okay, with open file, with open. Okay, so here what I'll do, file path, file underscore path. Okay, and then write byte. Okay, this is the write byte in the write mode. Okay, as a f. Okay, this is the file, then f dot write. Okay, I will explain guys why I am doing this. Okay, I will be explain this. Uploaded file, files dot get buffer. Okay, get buffer, and then I will be what I'll do, I will be appending this file path into this file path. Okay, file path, file underscore path paths, okay, dot append this file path, okay, in the file path. In the file path, this is the list, okay. In this list, we are appending this, okay. We are appending this into the file path, okay. So here guys, see what is I'm doing. Just uploaded file I will be storing in the my current directory, okay. So let's suppose I have uploaded file, okay, and then I will be iterating, okay. Uploaded file is there. This condition is true. Then I initialize this empty dictionary, empty list, and I will be iterating, okay, each of the files in the uploaded file, and then I will be joining, okay, I will be joining this current working directory and uploaded file name, okay. In the current working directory I will using this uploaded file dot name, I will be joining, okay, this file name, new file name. Then I will be open mode, okay, I will be writing this file in the open mode, file path write byte as f, then f dot write, okay, this uploaded file I will be reading and I will be writing here, okay, f dot write uploaded file, it will write written here, okay guys. Then what I do in the uploaded file, this list I have created, in the list I will be passing this file path, okay, what are the different file path I will be reading, I will be appending in the list, okay, this is my list, okay. So here guys, see, now we can go ahead and check this UI, rerun it, okay. So let me browse this file, okay, let me browse this file, attention. So this is one file I have uploaded, okay, let's suppose the one time, okay, this is the file uploaded, okay, as of now, but I haven't made any, okay. You can see guys, this file, are you able to see here this file in this my local system? Whatever the file is uploaded, just I will be storing here, okay, just I will be storing in the my file, okay, in the directory with the help of this function code, okay, this code uploaded file, in the file uploaded, then I will be reading this file in this current directory and I will be writing this in the current directory, okay. Then I will be storing in the file path, okay. This is how I will be storing this uploaded file in the current directory, okay. Any questions? Okay.
Is there no,
uh,
excuse me, hello?
yes,
Is there a way that you can automate all of that, all of what you've done?
sorry.
Is there a way you can automate all what you have done?
Yes, we can automate, right? We can automate this, all these, right, things. This is the workflow, right? This is the workflow we are staying, right, one step by step, right? Once we understood this, we can automate, right? In the upcoming, we are going to see how we can automate. How can we
Which
can
tool will you
automate.
use for that?
Sorry?
Which tool will you use for the automation?
Yeah, there are nowadays in the cloud, okay, in the cloud they are providing, right, different loaders, different chunking strategy, okay. We are going to see, okay, how we are going to automate this. But guys, as a data scientist, we have to develop this code, okay. We have to develop this code. As of now, this automation, right? As of now, this automation is not a perfect, okay. We have to develop this code as a data scientist, and then we can iterate over this, right? Which one the experiment, which loader is making, doing the good job, which chunky strategy is doing the well chunky strategy, right? We have to take the experiment, okay, and based upon this our experiment, we have to understand which loader is working well. We can chunking strategy we can use, which embedding model we have to use, which LLM model we have to use. We have to experiment with all these things manually. Just understand this first of all. Then there are the cloud provider, right? These are the different AWS, Azure cloud provider. They are providing this automation also. We can directly utilize this chunky strategy. By default, it will use the chunky strategy, all this. Okay, but as of now, we have to understand this. So then guys, we have to load this document. Okay, after this, we have to load this document. Okay, so load the document. So how do we load the document? We have to call this, okay? We have to call this load document. Okay, and here what I'll do, document equal to load documents, okay? Load documents. This is the function we have already defined above, right? Just I'm calling here and I will pass in this file paths, okay? I will pass in this file paths, okay? So here guys, see this load document is already defined. I have defined, right? This function here. Just I am calling here this load document. It will read the file path and it will use the loader, okay, for the PDF, and it will load all this document, okay, and it will store in the list, okay. Whenever you call this function, it will return the list of documents, okay, from this uploaded file, okay. So this is the documents, and we are passing this file path. Then what is the next step? So let me
Chunking and
yeah,
vector store.
let's clear, okay, the clear cache, okay, clear the cache if new document are uploaded, okay. So if the new document is uploaded, we have to clear the cache, okay. So cache memory we have to clear it, okay. So if uploaded underscore files, okay, not in st dot session state, okay, or we can say st dot session state dot uploaded files, okay, uploaded files not equal to uploaded file, okay, uploaded files, okay. So this is how I am defining this condition, okay. And then I will, what I'll do, I will dot st dot cache data, okay, cache data dot clear, okay. What is the data is cache, we going to clear it out, okay. If the session state is uploaded file is not in state, or this means whatever the uploaded file, right? If this current uploaded file is not in session state, or we can say other condition is session state dot uploaded file is not equal to uploaded file. In that case, we are going to clear this session state, okay. So this is how we are going to clear this session state. Then what we are doing, we are storing that, okay, new uploaded file st dot session state dot uploaded file, okay, dot uploaded file equal to, we are saving this uploaded file, okay. So this how we are storing this newly uploaded file, okay, in the session step, okay. Means what happened actually, guys, whenever you upload the one of the files in the UI, okay, whenever you upload the one of the files in the UI, this file, next time let's suppose this file will be stored in the session state. As of now, this whatever the file we are loading here, uploading here, it will be going to store in the session state. But let's suppose say second time I will upload the new file. So from this session state, it will remove this, okay, it will clear this session state, will clear this previous file with the help of this code, okay. And whenever we upload the new file, it will add this in the session state, uploaded new file, okay. So for that purpose, I have written this code, okay. Then we have to set up the vector store, guys, okay. Then we have to set up the vector store. In that vector store, what is the happening, guys? Can anyone tell me? In the vector store, what is happening? Here you can see we have defined this vector store, right? Let me,
Embedded and
yeah, you can see we have loaded only document, right? Then we are going to split the
chunking
document, right? Chunking. Then we are
and
embedding.
embedded and
Then we are
store.
doing the vector store, right? So if you call this set vector function, okay, we have to pass this document, uploaded document, and then it will create a return. What will it will return? The vector store, right?
Retriever.
Yeah, then it will return the vector store, guys. Okay, only vector store it will return. Then we are calling this chain, okay. Then it
Chain.
will return the chain, retrieval question answering chain, okay. So now you can see I am calling this function as vector store equal to setup vector store, and the setup vector store, what I need to pass? Document, right? I need to pass this document. Okay, I will pass in these documents. Okay. Then what is the next step, guys?
Chain.
So let's suppose what we'll do, we have st dot session state. Okay, what we can do, we can store these vectors. Okay, let's suppose every times we are passing this document to EY, and if the every time we are passing the same document, it will going to store in the vector store. Okay, we do not create the vector again and again for the same file. We do not need to create the vectors, right, embeddings again and again. For that purpose we are storing in the vector store. Okay, session state, vector session state dot session state. Then we are storing this into the just 1 second. Set conversation chain. Okay, set conversation chain, conversation chain. Okay, and we are passing this, we are calling this create chain. Okay guys, so we are calling this create chain. This is the function. Okay guys, see here, this is the function create chain, and we are returning this chain as a, by adding the retrieval then chain. Okay, we are returning this chain as output, and here we are, what we are doing in the chain, we are passing this vector store. Okay, we are passing this vector store, vector store, we are passing this vector store. Okay, so here guys, see, I am storing in the session state. Okay, st.session state, this conversation chain I will be storing as a vector. Okay, it will store the vectors. Okay, so then we are, let's suppose here guys, see, and we have to cache this data. Okay, we have to cache this data. For that purpose, what we are doing, we are adding this cache function here. Okay, so here what we are doing, cache the vectors. Okay, cache the vector store, vector store. Okay, now cache the vector store, we are using the st dot at the rate st dot cache cache data. Okay, cache data, and here we are using the persist. Okay, persist directory equal to true. Okay, persist equal to, so here guys, we are storing this vector in the memory, right, disk. So that's why we are passing this persist equal to disk. Okay, it will store in the our local memory, disk memory, and then it will show the spinner. Okay, when it is start this processing the data, it will show the spinning. Okay, spin. Okay, so this how we cache the data, means every time, so let's suppose the same document is there, it will not going to create the vectors again and again, it will going to catch, okay, these vectors in this memory. Okay, for that purpose we are using this cache data persist directory. Okay, and then here guys, we have stored this vector store in the memory. Then what is the next step? So here the next step is, let's suppose we have to display the chart history. Okay, so we have to display the chart history. Okay, let's come outside this. We have to display the chart history. Okay, for message in st dot session state. Okay, session state. Then we are in chart history. Okay, we are already initialized this chart history above. Just we are utilizing here. If the message in chart history, this message is not there in the chart history, what we are doing, with st dot chart message, in the we are passing this message. Okay, we are passing this message, and then we are passing this role here. Okay, this role is there, bracket close. Okay, so here then we are writing down st dot markdown. Okay, st dot markdown, we are storing this message here. Okay, we are going to see this message in the EY. Okay, of this content. Okay, st dot markdown. So here guys, let me save this code. You can go to this web. Okay, rerun this. Okay, it will not going to show anything. Okay, PyPDF. We need to install this PyPDF also, guys. Okay, so here you can see here pip install PyPDF. Okay, so here what we have to do, we have to store this PyPDF in the requirement files. Okay, so here PDF. Okay, okay, here we have to store this requirement file. I'm stopping, and I am running this requirement.txt. Okay, PyPDF. So it is getting installed. You can say it is getting installed. This PDF. Okay. So meantime, I will write this code. And then we are using this user input. Okay, it's user input in the UI. We are using the user input. Okay, and in the user input, we are passing this. Let's suppose the user role as a user and content as a user input or user query. Okay, so here let's see. Okay.
Ajit, have you still got a lot left?
Sorry.
Is there a lot left? It's already morning now. It's very
Yeah,
1
yeah.
a.m. So there's
I
still a lot
right.
left. And
We can stop here, guys. No worry. I already asked you, right? But
yeah, I
someone
thought maybe
asked.
you needed 1 minute or 2 minutes. I didn't know that you needed up to 10, 15, 20 minutes.
Okay, okay. So guys, it will okay. Tomorrow we are going to see. Okay, this continue half of the part. It's a 10 to 15 lines. It's only 10 lines code remaining, but we can see it tomorrow. Okay.
Okay.
Yeah. Bye. Have a great day, guys.
Yeah, bye.